This video we're going to talk about distance time graph. Last video we have learned to describe how fast an object moves. We can use the concept average speed. And average speed will equals to distance traveled over by time. This time we're going to learn about using a graph to represent the distance moved by an object. So let's have a look of these examples. So right now some students were doing a project studying motion of a bus. So they were at different positions between bus stop A and B and record the distance traveled by the bus at different times. So you can see that at the time 0 seconds, the bus was at bus stop A and start to move. So at 0 second, okay, there will be bus stop A, and then at time equals to 10 seconds, okay, it traveled by 150 meter. So say for example after 10 seconds, okay, it will be 150 meter away from bus stop A, and afterward, okay, you have another 10 seconds, so it will be 20 seconds. At this time you will travel in total 300 meter, so you add this up, become 300 meter. And then at time equals to 30 seconds, the bus stop at bus stop B, that is 450 meter from the bus stop A. So that means that, okay, you have another 10 more seconds, and then you traveled 150 meter again. So this one will be bus stop B. After that, okay, at time equals to 40, okay, the bus was still stopped at bus stop B. So therefore you'll find that 30 seconds to 40 seconds, the bus doesn't move anymore. So you will find that, okay, if we draw it out, okay, it will be quite complicated. Okay, this diagram is not very clear. So therefore we try to put it into a table. But before we draw we'll put it in a graph. But before we put it in a graph, we'll have to draw a table first. Before we move on to draw a graph, okay, we have to draw a table first. So for this times, okay, we will know that the independent variable, that will be the time. And then as time goes by, we're going to measure the distance traveled by the bus. So therefore distance in meter, that will be the dependent variable. So you should have a table like this. Other than that, okay, you have to write down the distance traveled by the bus. And then, okay, we're going to draw a graph, okay, for that one. For the graph, remember, the y-axis, we have to put the dependent variable, okay, right here. While the x-axis, we have to draw the independent variable. So the independent variable this time, it will be the time, and the unit for it will be second. While the distance, okay, will be the y-axis. So therefore the distance is put in here, and then we have meter right there. So roughly, okay, we'll find that, okay, for the first 20 seconds, it will going up like this. And then afterward, starting from 30 seconds, it will go horizontal. Like this, okay. Roughly the graph have to be like this. Other than that, okay, you should also include a title right there. Okay, let's have a look. The table right here, you have the independent variable, which is the time on the top, and then dependent variable. Remember, dependent variable will be always, okay, at the bottom row. Okay, and this will be the table for this graph. And for the y-axis, okay, it will be the dependent variable because it depends on the independent variables. Okay, so this will be the independent variable. Pay attention to the unit, okay? You must include the unit right there. And for the titles, because we're going to describe the distance traveled by the bus at different time. So this one is called distance time graph of the bus. So remember, each of the interval have to be the same. So therefore you'll find that will be each of the two intervals, two big intervals, it will be 100 here, 100 here. Okay, and then it have to be start at 0 right there as well. So you'll find that for the first 30 seconds, okay, it will steady going up like this, okay, up to 450. But after 450, okay, the other 10 seconds, okay, because it stay at the same place, so therefore it doesn't move, you will find that it goes horizontal. From this graph, we'll find that if the graph in the distance time graph, it go horizontal, means that the object have to be at rest. But if the distance time graph show a slope right here, it indicates that the bus is moving at a constant speed. That means the speed, it doesn't change, but it keep on moving. Say for example, the bus keep at a rate, say for example right here, okay, for 10 seconds, it moved by 150 meter. So 150 meter over by 10 seconds. So actually it's moving by 15 meter per second. Okay, so we'll know that, okay, moving at a constant speed, the speed will be 15 meter per second right now. Okay, but if it is horizontal, that means it is at rest. So let's have a look of another examples. It is also in your book. You find that right here, if it goes by 10 seconds, okay, these objects, it will move by 160 meter. If it is go by 25 seconds, if we're just going up, hitting this graph, we find that it will be 400 meter. So say for example, 20 second read from the graph, what should it be? So for 20 seconds, it going up like this, and then hitting right there. The answer for this one, okay, you have to calculate the small interval first, okay. Right here, okay, 5 small interval equals to 400 minus 300, that means 100 meter difference. But you're going to break it down into 5 small intervals, so each of the small interval represent 20 meter. So therefore this one will be, this reading, it will be equals to 300 plus 20, so therefore it will be 320 meter. So that means that at 20 seconds, okay, it will reach 320 meter right there. So right here we got two different distance time graph. The first one is a horizontal one, okay. So for horizontal, just now we have learned that, okay, horizontal actually it means that the object is at rest. Okay, because at time equals, say for example 5 seconds, 10 seconds, 15 seconds, you find that all the time it stay at the same position. Therefore actually the object, it doesn't move. Okay, so we say that the object is at rest if the graph it shows a horizontal line. However, okay, if it's a slope, okay, with a graph with a slope, okay, the slope can also be different. First of all, it can be a steeper slope like this, a steeper one, or a flatter slope. So when you look at this, okay, we can see which one have to be faster. Say for example, okay, they start at the same time, which is 0 second. Say for example, after 10 seconds, this is 10 seconds, we can see that the distance traveled by I, and also the distance traveled by second, okay, I and number 2, okay, we find that I, okay, it will travel a further distance than the second one. Okay, say for example, this one may be 80 meter, or maybe this one only 20 meter. So we will see that a graph with steeper slope, that means the object, it will be moving faster. It represents a faster object. While this one, okay, a graph with a flatter slope, will know that, okay, it will represent by a slower object. Okay, this one is a very important concept. Okay, horizontal, that means the object's at rest. A steeper slope, that means it moves faster. A flatter slope, it means it moves slower. So right here, okay, we'll do a summarize. Okay, we find out the distance. This one is a graph with a slope right there, so therefore it is a moving object with a steady speed. But we found that, okay, if it is a horizontal line, that means that it is at rest. Okay, so if it is steeper slope, okay, move faster. Less steep slope, okay, that would be slower. So checkpoint, okay, have a look right here. So first one, 1A, 1 unit of the speed is s meter per second. So this one should be wrong, okay, because it should be meter per second. Okay, so this one is false. The distance time traveled, the distance time graph of an object is horizontal line. Okay, the object is at rest. Okay, this is correct. Okay, just how we mentioned already. So right here, what is the distance traveled by a car in the first 10 seconds? First 10 seconds, it goes around 100 meter. Remember the unit. Okay, very important. Describe the motions of the car from time equals to 0 to 25 seconds. So you can find that, okay, the first part from 0 all the way to 15. 0 to 15 seconds. Okay, we found that the car moves at a constant speed. But after that, okay, it's time from 15 seconds onwards. Okay, from 15 to 25 seconds, okay, the car is at rest. Okay, so this video, or to summarize this video, we'll find that, okay, a distance time graph, okay, of an object. It shows the distance traveled by the objects over time, and we have learned different form of the graph. It represents the meanings of it. So the one with a slope, it means that it moves at a steady speed. If it is a horizontal one, it means the object at rest. A steeper slope means move faster. A gentle slope, okay, it means it's move slower. Okay, so that's all for this video. Bye bye.